Hello everyone, welcome back to Life Technologies YouTube channel, and thank you for watching and supporting our channel. So this is another episode of our IPRAN training series. Remember, in this series we discuss how to deploy IPRAN technology on service provider network. So in our previous episode, we've discussed the general architecture of the IPRAN technology. We have also discussed how to design different protocols, the IGP, SIS, BGP, and MPLS for the service provider network. We have also did a lab simulation of how to configure this protocol, SIS and BGP, and even MPLS on IPRAN network. And in our last few episodes, we've been discussing how to deploy mobile services on service provider network. So we did a lab simulation of how to configure services, the VPNs for different radio access technologies, 2G, 3G, 4G, and even 5G on the service provider IPRAN network. So if you haven't watched our previous episode, check them on our channel. They will help you to understand the IPRAN technology and how it can be deployed on service provider networks. So in our last episode, remember we discussed how to configure services. We did a lab simulation of how to deploy mobile services on service provider network. So we did uh, design the network having different VPNs for different radio access technologies, and then we did the necessary configurations. But we realized that we still need to do more on the route exchange. So remember that we have the RSG connecting to the controller. So the RSG is connecting to the controller, and then we have the BTS connecting to the CSGs. So we need to ensure that we have a mechanism to exchange the routes all the way from the CSGs to the controller, and we also need routes to be propagated all the way from controllers to the CSG. So we need to have the bidirectional route exchange between the entities from the radio side to the controller side. And this route exchange should be done through our IPRAN network. Remember, the RSG is connecting to the controller, so it has to have the routes to the controllers. The CSG is connecting to the BTS. So all the routes, all the subnet that are configured on the BTS should be advertised by the CSG to the ASG, and the ASG should also advertise the route to the RSG. The controllers, many times we have a static route or a default route, so it will have a back route for any route that is going toward the BTS. And same way, we have the routes of controllers on the RSG. So the RSG should advertise the route to the ASG, and the ASG should advertise the route to the CSG. Once we have the proper route exchange, we can now have end-to-end connectivity from the BTS to the controllers. So we can have different mechanisms to achieve this, and this is why in this episode and upcoming episode we'll be discussing the HVPN solution, so the hierarchical VPN solution that is commonly used on IPRAN network, especially for the service provider network. So this one will help us to achieve the route exchange between different nodes, between different entities on the IPRAN network. So traditionally we have the flat network. So the flat network means that all the PEs must have high performance, because all PEs should be able to handle the routes, should be able to process the packets and handle the routes from all the VPNs, even the local and the remote VPN. So this one requires that all PE routers on the service provider network should have high performance and be able to handle the huge number of routes on the MPLS backbone. So no matter it's the RSG, no matter the ASG, the CSG, remember they are all acting as the PE routers on the IPRAN network. So they should be capable of handling the many number of routes that are exchanged on the service provider network. But generally, when we are setting up the IPRAN network, you realize that we are using different types of services. I mean the different types of routers as RSGs, ASGs, and CSGs. CSGs, normally they are just the low-end routers, just 1U routers, the compact boxes that are used to just connect to the BTS. They could be even a switch, a simple switch. It could be a Huawei switch, it could be a Nokia switch, it could be a Juniper or Cisco switch, or even the low-end devices are the ones that are deployed as access devices, and many times they don't have the required high performance to handle the many number of routes or to process all the routes that are exchanged on the MPLS backbone. So they end up having low performance. So you know that the access devices on IPRAN network have low performance, and this could affect the network performance. So if they are not able to handle the routes, we end up having, maybe we have so many routes being exchanged from the RSG, from the ASG to the CSG. And if the routing table is full, it means it has to drop other routes, other service route, and it could even impact the general performance. So that's why we need the HVPN solution that will help convert the flat network into hierarchical network model. So we are now moving from a flat network into a hierarchical network model. So that is the HVPN solution. So next, why do we need HVPN on IPRAN? So I've said that HVPN stands for hierarchical VPN. So you can see that generally the service provider network, we have the provider edge routers, we have the provider routers, and then we have the PE. So this is a kind of a flat network. We have the PEs, we have the PEs. So the PEs are exchanging the VPN routes, and they should be able to handle all the routes that are exchanged on our MPLS backbone. And remember, the service provider network, it's very huge. It has so many routes, it has so many services, it has so many nodes. So many services are deployed on it, so many VPNs. You can see that in this setup, we only have two VPN, VPN1 and VPN2. But in a scenario, a real live network, then we have so many VPNs because we are carrying many services on the service provider networks. So the normal BGP MPLS IP VPN just uses a flat network model. So it means all PEs should be the same. They should be having the same performance. But then we are using BGP to advertise the VPN routes and MPLS to forward packets on the service provider backbone network. Remember, with the BGP MPLS, of course, we are using BGP to exchange the routes, and then MPLS because we are doing the label switching. So MPLS is used to forward packets on the service provider's backbone network. So all PEs are required to deliver same level of performance. All PEs should be the same. They should be able to handle the many routes on the service provider networks. And whenever we have performance issues of some PEs, maybe if you deploy a low-end device in some location as a PE, it will end up having low performance, and then it will affect the performance and scalability of the entire network. Remember, if one device is not able to perform well, it ends up affecting the performance of the entire network because it may not be able to advertise or to handle all the routes that are being exchanged. It could be dropping some VPN routes, so we end up impacting the performance of the network. So with the HVPN solution, we are distributing the PE functions across multiple PEs. So we are building a hierarchical network. We have different levels. We have maybe the aggregation, the access, we could have the core. So we end up distributing the PE function across multiple PEs. So the low end, the access PEs really doesn't have to have the same performance as the aggregation PEs or the core PEs. So we are distributing the PE functions across multiple provider edge routers in the network. This is why we need the hierarchical VPN on the service provider IPRAN network. So the main advantages of HVPN, you can see that this is a typical HVPN network. We are having different devices. We'll go through them in detail, their functionalities. We have the NP, we have the SP, and then we have the UPE. So you can see that we have hierarchical architecture in this HVPN solution. We have the aggregation. So the aggregation will have the NPE and the SPE. So SPE is the boundary between the aggregation and access. And then we have the SPE acting as the point of connection or the boundary between the aggregation and access. And now we have the device that are connecting to the user equipment, the UPE. So in the IPRAN network, you can take the UPE as the CSG. The SPE will be the ASG, and then NPE will be the RSG. The CEs, these are the BTSs that are connecting to the BTS that are now having the services, the 2G, 3G, and even the other radio access technologies. So one advantage of HVPN, it provides high scalability. Remember, you've distributed the functionality. So you can easily scale your network. You can easily deploy even low-end devices on your network. And it's very easy to expand your network with the HVPN solution. Remember, you have the aggregation, you have the access, so you can deploy low-end devices in the access, and then you maintain high-end devices in the aggregation network. Another advantage of HVPN solution, it conserves limited interface resources. So for the SPE-NP connection, we just need one connection. We don't need many connections for the different services or for the different VPNs. We only need one connections on there. So the interfaces required for the SPE and the NP, we don't need that many, just maybe one to interconnect between the two, and all the services will be carried over that one connection. But sometimes, of course, we end up having multiple connections for protection. We are relieving the burden of lower level PEs. They only have to maintain local routes. So the UPEs or the CSGs in this network only have to maintain the local routes. So we have reduced the pressure, we have reduced the burden of the lower level PEs, and then we can be able to deploy low-end devices. For Huawei, we can be having the ATNs, the different ATN versions acting as the UPEs. And then many times we have the CX or the NE8000 acting as the SPE and the NPEs. So another advantage, it's reducing the configuration workload. The lower level device only needs to establish only one MPBGP peer relationship. So we are only establishing one MPBGP peer relationship with the SPE, from the UPE to the SPE. But remember, in the traditional architecture, you have to establish peering between the PEs, like a meshed kind of peering between the PEs, or you need to establish a peering with the RR. So with the HVPN solution, you only need to establish, the lower level device only needs to establish only one MPBGP peer relationship with the SPE. But then if you have a setup, kind of a ring setup, then you end up having two peer relationship for the UPE just for protection. Remember, we need to protect the services, so you can establish two BGP peering session between UPE and SPE for protection. For example, in this setup, you can have a peering relationship from UPE2 to SPE1 and also to SPE2. So in case we are losing this device, the services should be able to flow to this SPE. If we are losing this device, we can still forward the traffic via this SPE. So these are the advantages. Scalability, conserves limited interface resources, relieves the burden of lower level PEs, reduces configuration workload, and even it's very easy to manage the routing information. Remember, we have different models of HVPN, which we'll discuss. You can be only forwarding the default route to the UPE. It doesn't have to handle any other route. So that's why it only maintains the local routes and reducing the pressure, because it doesn't have to process those so many routes that are coming from the other PEs, the aggregation PEs. So device functionalities in HVPN solution. So I've mentioned that we have the NPE, we have the SPE, and the UPE. So these are the three main devices in HVPN solution. So the UPE, this one we call it the underlayer provider edge, or sometimes we just refer to it as the user end PE. So it's the user end provider edge router. It's responsible for access, for user access. Remember, it's the one that is connecting to the BTS and only maintains routes of directly connected VPNs. So it only maintains the routes of the directly connected VPN, and we can have a summary or a default route for remote VPNs. So the UPE will assign inner VPN labels to the routes of its directly connected sites and uses MPGP to advertise the labels to the corresponding SPE along with VPN routes. So this one will add inner label and advertise the directly connected routes to the SPE. So, and it uses the default route or a summary route to access remote VPN. So whenever it doesn't have the route, it will just use the default route or the summary route to access the remote VPNs. The SPE, that is the superstratum PE, or we call it the service provider PE. So the service provider PE, you see it sitting in the middle of the UPE and the NPE. It maintains and floods VPN routes. So it's in charge of maintaining and flooding VPN routes in the network. It maintains all VPN routes, so it will have to keep all the routes, as opposed to the UPE, which only keeps the local routes. So it will keep both local and remote routes from remote sites. So that is the SPE, the service provider edge. And then we have the NPE, which we are calling the network provider edge, or the network provider NPE, which is connecting to the SPE to learn routes from the UPE. And then it also connects to the controller. So the NPE, the device that will be connecting to the controller. So in our IPRAN setup, this is just an RSG. So it will be the RSG that is connecting to the controllers. For SPE will be the ASG. So we have an ASG here. And then for the UPE, this is a CSG. So they perform the same functions when we come to the IPRAN. Remember, HVPN solution is what will be applied on the IPRAN architecture. So we have the RSG acting at the NPE, we have the ASG, the SPE, and then we have the UPE, which will be the CSG. So I mentioned that we have the three, the UPE user, the underlayer provider edge, or the user NPE. We have the SPE, the provider, service provider PE, and then we have the network provider edge, the network provider NPE that is connecting to the controllers. So for the route exchange, of course, we have the route coming from the UPE to the SPE, then SPE will be in charge of advertising the route to the NPE. Any route coming from the NPE will come to the SPE, then SPE will be in charge of advertising the route to the UPE, depending on the architecture that we are using. So these are the three key elements, three important devices on the HVPN solution for the IPRAN network. And then we have different HVPN models. So we have HVPN, the hierarchy of VPN. So with the hierarchy of VPN, we have the SPE advertising only default route to the UPEs. So remember, we have the route that are coming from the NPE to the SPE, and then SPE has to advertise the route to the UPE. So with HOVPN, the hierarchy of VPN solution, we have the SPE advertising only the default route. So this one only advertises the default route, the SPE towards the UPEs. So the UPE did not have specific route to the NPE. Anytime it has to access the remote VPN, it will use the default route that is advertised from the SPE. And then, so this one helps us to implement route isolation, and it allows devices with low route management capability to be used as the UPEs. So remember, I mentioned that for the access nodes, many times we are using low-end devices, so they don't have the capacity to manage many routes. So we are using low-end devices as the UPEs, and then they can only have the local routes and the default route that is accessed, that is advertised from the SPE. So this one reduces network deployment cost. Why? Because remember, we are deploying low-end devices. The cost of purchasing a low-end device that will be used as a UPE is much lower compared to the cost of purchasing an NPE, the RSG device. For scenario in Huawei, for example, the cost of purchasing an ATN, or for Nokia, the cost of purchasing an IXR is much lower compared to the cost of purchasing an SR2S for Nokia, or the CX600X8 for Huawei, that will be used as the SPE or the NPE. So this one is helping to reduce the deployment cost for the service provider network. We can use low-end devices at the UPEs, which are always the majority. Remember, in the network, we normally have many UPEs because we have so many BTS, we have so many inode Bs, we have so many remote sites. So, and they end up aggregating on the SPE. So with the HVPN solution, we are only advertising the default route to the UPs. The specific routes are not advertised to the UPs. Then we have the HVPN, the hierarchical VPN solution. So this one, SPs can advertise specific route to the UPs. So this is the HVPN. With HVPN solution, we have all routes being exchanged between the SPEs and the UPEs. So the UPEs should be able to handle the specific routes that are advertised from the SPE. So the UPEs will be functioning as a RAR client to receive the specific routes reflected by SPE. So we have the SPE acting as the RR, and then the UPEs are the RR clients that will have to handle the specific route that are received from the SPEs. So this one helps to facilitate route management and traffic control. So remember, when you have specific routes, then you can find the best path to a solution. But for the HVPN solution, you only have the default route. So any traffic, you have to send it to the aggregation node. What if maybe the router that you are trying to access, maybe the specific IP that you are trying to access, it's on this node? You still have to use the default route to send the traffic to the SPE, and then SPE will have now to forward the traffic to the UPE. So this one, sometimes it results into an optimal routing of the traffic. So these are the differences. These are the two models: HVPN specific routes advertised to the UPEs, HVPN specific routes are advertised to the UPEs. So we have the HVPN and the HVPN solution that can be used for the hierarchical VPN model. Then the comparison between the two. So I mentioned that with the HVPN, we are advertising only default or summary routes to the UPEs. With the HVPN solution, we are advertising all VPN route to the UPEs. So they should be able to handle the many routes that are being exchanged from remote PEs. For HVPN, VPN instances must be configured on SPEs for SPE to import default route locally and to summarize routes received. Remember, before the SPE is able to advertise the default route to the UPE, first it has to have the route. So that's why we need to configure the VPN instances on SPEs, so that it can be able to import the default route locally and to summarize routes received from remote sites. So the VPN instances must be configured on SPEs. Then with the HVPN solution, the VPN instances do not need to be configured on SPE. And then another difference is an export policy is configured on SPE to advertise summary or default routes to the UPE. So remember, before we are able to advertise the default route, we need to configure route policy. So we always configure an export policy on the SPE to advertise summary or default route to the UPEs. If you don't configure the export policy, then you end up having all the specific routes advertised to the UPE, which is the HVPN solution. So for HVPN solution, MPGP relationship is configured between the UPEs and SPEs and between SPEs and UPEs. So the UPEs and UPEs are configured as the RR client of the SPE. So all routes will be advertised between the UPE, the SPE, and the NPE. So these are just some differences between the two solutions, HVPN and HVPN. But the key focus is on the route advertisement. The SPE will advertise only default or summary route, but with the HVPN solution, the SPE advertises all VPN route to the UPEs. So I hope you've enjoyed this session. In our next episode, we'll be looking at how the route exchange or how the traffic is forwarded with HVPN and HVPN solution. If you've enjoyed the session, kindly hit that like button. You can leave a comment, and also please remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.